Good afternoon or good evening, everyone, depending in which part of the world you're in. And welcome to today's webinar hosted by Bandweaver. I'm Richard Cluth. I'm Managing Director of Bandweaver, and I'm delighted to be your host for this session. I've worked in fibre optic since 1994 and with Bandweaver for more than 20 years. Before we get started with the webinar, just a bit of housekeeping, let you know how it works. So we will be recording this session, and this will be made available afterwards if you want to download it. Throughout the way we'll run it is Marinus will present the webinar, and if you have any questions, please put them in the chat in the Q&A box. Throughout the present, and we'll have a dedicated time at the end of the session to address as many of them as we can. If we don't get to your question during that final question session, we usually have quite a lot, then we will get back to you afterwards. So please don't worry, your question will be answered. Now let's move on to the main reason you're here. So I'm very pleased to introduce our speaker today, Mr. Marinus de Heide. He is a business development manager with Bandweaver. Marinus has over 25 years of experience in UK with safety, fire and security related products. Previously been responsible for setting up distribution networks in Europe and the Middle East for fire alarm systems and cloud-based platform solutions. Marinus is based in the UK, and the focus of his role with Bandweaver is on developing fibre optic linear heat detection products. And this is in markets varying from transportation applications such as road, rail, tunnels and car parks, through industrial applications, including conveyor belts, factories, warehouses and PV installation panels. So today, the talk is titled, Keeping Conveyors Moving, Next Generation Safety with Fibre Optic Linear Heat Detection. And conveyor belts, they're the lifeline of industries, in industries such as mining, power, generation, ports, manufacturing, but they also present one of the highest fire risks. Traditional detection methods often react a bit too slowly to this, leaving critical infrastructure and safety at risk. So in this session, Marinus will show how Bandweaver's fibre optic linear heat detection systems provide comprehensive protection for conveyor belt operators. So without further ado, I'll hand things over to Marinus. Marinus, over to you.
Thank you, Richard, and thank you for the introduction. Good morning to everybody from the UK. I'm glad you joined us here for this webinar. So, what are we going to cover today? First of all, a few conveyor belt detection challenges with some fire that have happened in the past. An introduction to fiber optic linear heat detection, also called LHD. Some case studies where we've done some practical installations all over the globe. Some details about Bandweaver, of course, and a Q&A session at the end that Richard already mentioned. So please send your questions in so we can answer them at the end. Why conveyor uptime and fire safety are mission critical? Conveyor belts are the lifeline of operations. They're central to moving bulk materials efficiently over long distances. It can be from 10 meters up to kilometers of conveyor belts. And a single conveyor belt outage can hold an entire production line or mine or industrial facility, costing millions. At these conveyor belts, fires are a constant risk. The consequences of fire incidents are therefore severe. Just downtime, lost production, can be hours, days, sometimes months that there's nothing happening. This can cost millions or sometimes even hundreds of millions. There's also risk to safety, risk to personnel in remote or enclosed environments at these industrial facilities. The risk to assets, damage to the belts themselves, the motors, the infrastructure around it. It's costly to repair. And it's also got a regulatory and insurance impact. If there is a fire, the insurance company will probably come and visit you, raise the premium, obviously, and also tell you that you need to change a few things on the site. So which fire risks are there for conveyor belts? The main risks associated with belt-type conveyors are as follows. So there is more than these, but these are the main ones. So friction due to a loss of belt traction and slipping on the drive roller. There's also something called hot works that probably a lot of people are familiar with, especially welding activities can generate hot molten material, and if that falls on the belt, obviously it will cause a fire. Also, other overheated material which are placed on the belt. A buildup of materials that have fallen off the belt and dust cloud generation causing dust explosions. And then static electricity. And the main one that we're focusing on really with the linear heat detection is bearing failure. So historical conveyor belt fires. We're listing here more than 200 fires in the last 10 years, but there is probably a lot more that have not been recorded. And with a cost per fire on average going over 2 million, but sometimes over hundreds of millions, is definitely something to bear in mind. So we're going to look at a few fires. First at the Dong, which is the Danish oil and gas company, which has now been renamed to something else in 2017, but at that time it was called Dong. In Avedeur, where there was a biomass pellet handling facility, which was in August 2012. But there were later related incidents at other biomass facilities. We're going to look at a dust explosion in a grain silo in France in 2018, and last of all in the UK, the Montans molding plant, where there was a fire first in 2018, but then in 2020 and 2024, there was a subsequent incidents. So the fire at the Danish oil and gas facility in 2012. A large fire at the event started in the conveyor, in the electrical conveyor belt system and spread afterwards into silos and storage. The impact of that was a lot of plant damage, but also there was a long shutdown and the repairs had to take place during this time. Extensive smoldering in similar storage silos and other plants prompted a review of pellet handling safety across Europe. So this one fire sort of put the attention onto this, but then other similar incidents set off another thing. So, and the next thing, as you can see on the image, there was extensive damage as well, is a port-based grain silo in France. And this fire happened on the 23rd of February 2018. What happened exactly? A dust explosion occurred in a port silo complex. The ARIA, which is the French accidents database, investigated, and the summary said that the origin was linked to a collapse and then the heating up of a bearing at the head of an overhead conveyor. An idler, so drive bearing, heated and became the ignition source. So this is a typical example. So the impact, there was several injuries, and it caused a major local response, but damages were huge, and companies suffer for this. So, and the last one we're quickly talking about is the one in the Montans molding plant in Stowmarket, Suffolk, where multiple conveyor belt and silo fires happened in 2018, 2020, and 2024. In October 2018, an operator detected a warm screw conveyor, and the source of burning was traced to that screw conveyor. Fire crews then extinguished the smoldering before a larger explosion happened, but later events in January 2020 and January 2024, the same site involved smoldering in dryers and silos and required multiple times for the fire appliances to respond. So, what are the challenges of conventional fire detection systems? Because there is various type of fire detection. It's not just fiber optic linear heat detection, of course. So first of all, you got your typical point heat and point smoke detectors. They will only monitor at a fixed spot an area, And if you have very long conveyor belts, unless you install a hell of a lot of point detectors, you will leave some gaps along this conveyor. So for longer conveyor belts, the point heat and smoke detectors are just not very practical. Then we've got something called electrical, what I call a traditional linear heat detection, which is basically two copper cables or two metal cables with a kind of glue in between. When the glue melts, it makes contact and sets off an alarm. Provides a simple on-off alarm, doesn't necessarily give you a precise location. And because the glue is melted, you will need to replace that section and sometimes the full cable after an activation. So if you got a lot of false alarms, this can become very costly. Then there's also something called infrared or thermal imaging cameras. They require a clear line of sight. And at these industrial facilities, there's normally a lot of dust, dirt, poor lighting, which reduce the performance and can also cause false alarms. So again, it's not very practical. Same thing with flame detectors. They detect only once the flames are visible, which is too late for smoldering hotspots from overheated rollers or bearings. And then last of all, we got spot type temperature sensors, but they only cover an individual roller or bearing, making them again impractical for long belts. And you will be missing issues or elsewhere if you don't cover every bearing. And on 10 kilometers of bearings, that would make a lot of temperature sensors. So the advantages of fiber optic linear heat detection, they include very robust cable construction, which we'll look at later, and we can detect over very long lengths of conveyor belts. A minimal need to site control equipment, so we only need the cable in place in remote locations. And it provides an actual temperature measurement very accurately, continuously along the whole conveyor belt length. It can predict before the ignition occurs with our smart alarms. So system activation becomes a maintenance alarms. And this is what I always try to emphasize to operators. What we're trying to do is prevent a fire, not detect a fire when it's too late. So a maintenance alarm is much better than a fire alarm. This fiber optic linear heat detection is also not affected by radio frequency interference or electromagnetic interference, and it's inherently safe. We have got an EX approval, which makes it suitable for use in hazardous areas. So this fire profile you can put into any fire, but this is typical for a fire profile for a conveyor belt. So the very early stages, early detection, preferably before there's a fire. You can still do something with the maintenance team. But when there is an early detection, the suppression system will probably be able to suppress the fire. Once the fire develops further, fire suppression might still work, but there is a big chance that it will develop into a thermal momentum, what we call it, in which case it is just watch and look everything go up in fire, and at that time it is far too late. So what we want really is detect in or even before the green zone. So yeah, a little bit of tea first. And then there's a lot of abbreviations with linear or with fiber optic linear heat detection. So DFOS stands for distributed fiber optic sensing technology. What are the benefits of DFOS? Information benefits. So it's a high probability of detection, typically over 95%, which is achieved by our smart alarms. Low nuisance alarms, again, because these smart alarms, which we will cover later on. Location accuracy on a 10-kilometer cable, we can still have an accuracy of more or less a meter. Gives you very early detection, and because of all these, we can improve on the decision making. The physical benefits then: immune to electromagnetic interference, which at the industrial facilities is particularly important. We have got something called cut resilience and redundancy. Again, we'll cover later. Minimal maintenance requirements. We're only sending a laser through a cable. We don't need to do anything to the cable to maintain it. There's a long lifetime as well of these sensor cables, over 30 years, and sometimes we've seen examples that cables have been installed in the 80s, so it's 50 years or over sometimes. A fast installation and system setup, so we can be up and running in minimal time. There is no power or electronics required in the field. As I said, there is only a laser light going through a fiber optic cable. And last of all, especially in these industrial facilities, it's unimpacted by dirt, particle, line of sight, movement. It is only a fiber optic cable. So the financial benefits at the end: a low total cost of ownership, reduced infrastructure costs, disaster prevention, which will save a lot of cost, reduced downtime, which is the same, and preventative maintenance, because when we detect a heat up of the bearing, we can just replace it. So an introduction again to distributed fiber optic sensing, the technology itself. We're dealing with something called distributed temperature sensing, where the fiber is the sensor. We do not need any point or specific sensor. The main thing to remember here is that the whole fiber cable senses. And the system uses standard telecoms grade optical fiber. The technology is based on something called OTDR, which stands for optical time domain reflectometry. So a little schematic with an example of how this works. So what we're doing is we're sending a laser through a cable. This travels with the speed of light, which is roughly 300,000 kilometers per second. And the reflection of this light we measure. And we can then, if the temperature changes by 0.1 degree, we can see the location by roughly half a meter to a meter accurate. So it's a very accurate system over long distances. So therefore it is very suitable for conveyor belts. The system works on a time of flight principle, if you're familiar with that, which is similar to radar. The main thing to remember is really the fiber is the sensor. It's not the cable. This is a mistake. The fiber is the sensor. We do not need any dedicated sensors. So there's complete coverage along the entire cable length, and it gives you very simple installation and planning. So this shows you how it is next to a conveyor belt. So the cable itself, it's an AT cable where AT stands for armored tube. So it's got a metal covering in it and also Kevlar. So it's a very strong and robust cable. There's no maintenance required. It's a totally passive sensor, which makes it suitable for industrial installations. There's also no moving parts, only a laser going through it again. And it's not susceptible to corrosion. The design lifetime of over 30 years. And again, immune to electromagnetic interference and also radio frequency interference. And there is no infield power or comms required. And it's also very lightweight and flexible. It makes it easy to install. And just to give you an idea, a kilometer of cable weighs 21 kilograms. It's easily to handle by just one person. Other type of installations, or what we mentioned earlier on, the electrical linear heat detection, they have a much higher weight because of all the metal inside. So our cable is very easy to install. So a little video now. You can get it to play. A little video that shows our system and the benefits it offers really. So this is the front of the unit where you have an LCD screen, so you can program the unit. It's completely passive, the cable, as I already mentioned. No apertures, joints, or moving parts. Events can be viewed and system configured by the built-in LCD touchscreen display. At the back of the units, we can connect to SCADA building management systems via the built-in Modbus adapter. So the fiber optic cable, this is an example of an installation in a building where the cable is near to the ceiling. We can detect the fire anywhere along the length of the LHD cable. And again, there is complete coverage of the assets with no gaps. We're also connected via relays to a fire control panel. And when we detect an increased temperature, it exceeds the thresholds of the alarm. An alarm condition is created. Generates alarm based on the calculated temperature profile, and then we can reset the alarm. We can see here through a little lockable So next, we're going to potential cable position on the conveyor belt. The main thing to remember really is that you want to be as close to the bearings as possible so you can detect the temperature change quickly and deal with it efficiently. Every frame that I've seen in the field is different, so cable positions will be different as well. If you're close to the bearing and, for example, you get a rate of rise alarm, you can still prevent a fire. The overhead cable in the hood, if there is a hood, that typically detects a fire when there's flammable material that is called fire. So that will be more for a fire detection position. A few examples of different clamps and clips, which you can find in any hardware store, and it's just a matter of selecting the one that's most suitable for the frame you've got in place at your facility. So there's clips, L-shaped clamps, steel P-clips, and there's various other type of hardware that you can use. So on the right-hand side of this slide here, you can see a cabinet which has the unit inside it. And on the left-hand side, it's a typical system architecture where we can connect the DTS unit to a fire control panel via the relays, as we showed in the video. But we can also connect via Modbus over TCP to PLC, SCADA, BMS, or building management system to give more precise information. And what we see here is a loop configuration. So the cable, would be a 2-channel unit, so the cable comes out of channel 1 and goes back into channel 2, making it a redundant system, which we'll cover in the next slide. So a loop configuration, cable redundancy with a single cable. Every cable is 2 fiber cores, so you get 2 for the price of 1, you can say. So if there is damage to the cable, there is still a fully functioning system. So I'll show that here. So the red fiber will start at channel 1, but will terminate just before channel 2. So the laser goes through it like that. And then the green cable will come out of channel 2, go back and terminate just before channel 1. Now, if we get a cable cut, still means the laser will go through the red fiber and the green fiber up to the cut. If there is a cut, you will get an alarm and a fault. With the location, so you can then go and repair the cable. A little bit about the smart alarms we've already mentioned. Also call them intelligent alarms. They're fully configurable in the software, maximum versatility with overlapping zones, different alarms in different zones. It's not restricted by the hardware, and we can have up to 1,000 zones per unit. And all these zones are fully customizable, so we can have different types of alarms in different zones. You can have shorter zones or longer zones, overlapping zones. So as I mentioned, it's completely configurable in the software. And this customizable, it gives you a rapid detection, accurate location, and low levels of false alarm. So what we got? We got a maximum temperature. It's typically 30 degrees above the maximum ambient temperature. So temperature sets normally 60 to 80 degrees. We got a rate of rise alarm, typically around 10 degrees per minute. But as we will see in some of the case studies, people also set them at a lower level to get a quicker alarm. And then last of all, we got a deviation alarm, which is again typically set 10 degrees above the zone average. This is what it looks like when you need to program the unit. So as I said, it's software configurable up to 1,000 zones, which gives you complete flexibility with overlapping zones and different outputs. We can name the zones, so we can have up to 1,000 zones with up to 1,000 different names. We can then have the relay outputs. We can start and stop the lengths. For example, your control room, you've got the unit, and your first conveyor belt is 100 meters away. Your zone will start at 100 meters, and if it's a 20-meter belt, the zone stops at 120 meters. And we can then also set different smart alarms at these zones. So we can have a maximum alarm number 1. But we can also set a maximum alert number 2. For example, if you want a pre-alarm at the lower level. So if you have a maximum alarm at 60 degrees, you can set a pre-alarm at 50 degrees. You can then send somebody to have a look and see what's happening. It's not necessarily a fire. An alarm is not set off, but you can check what's happening. And the same with the change rate and the deviation alarms. So just a quick reminder, submit any questions you may have by clicking on the Q&A button.
I just want to interrupt at this point. We're having an issue, some technical issues with the interface. There isn't a Q&A button on this. Unfortunately, there is a chat button, but some people are saying they're having issues. So you can direct a question to either Marinus or myself, or as said, as an alternative, please send an email to info@bandweaver.com if you're not, and we'll try to get to your questions. So many apologies for that technical issue, but yeah, please. I put the email in the chat as well, but many apologies. Sorry, Marinus. I'll let you carry on there.
Thank you for that, Richard. Great to see that live webinars are not always run perfect. So a few of the case studies now. I'm going to cover 3. One is the first one is the Yeniköy, if I pronounce that right, power station in Turkey. In Limerick, there's a cement plant in Ireland, and then a paper factory in Thailand. So the Yeniköy power station, 420 megawatt coal-fired power station. It's owned by Limerick IC. 10 million tons of coal per year are transported through a conveyor belt system. And obviously, therefore, it's a critical power infrastructure and highly flammable product, which requires advanced detection. At this power plant, we had 20 kilometers of belts monitored, which required also advanced visualization, so people could go to the right location. Because if you got 20 kilometers, it's necessary to have advanced visualization. So we used one single unit, a 10-kilometer unit with 4 channels, so it could monitor up to 40 kilometers of cable. But we split it up in 714 zones, which were all 30 meters in length. So the total monitoring we did there actually was 21.4 kilometers. We set 2 of the alarms. For the maximum temperature, we set in different zones from 57 to 61.5 Celsius. The rate of rise, we set at quite a low range here, 5 to 7 degrees. And we integrated with a Panasonic CCTV monitoring station via the relays, but we also used our in-house MacView. So there's a few slides on it, but it is really a different type of product, which we market next to our linear heat detection. So is where you can see the interface in the control room and the FireLaser in the instrument rack, and you can see the LCD screen there. The installation of the cable itself, and as you can see, it was installed quite close to the bearings themselves. And as you can see, BTS is our exclusive distributor for Turkey. They also provided customer training locally. So here's where you can see a little bit more detail on the installation of the cable itself. So you can see it is quite close to the bearing itself, or the air of heating and the detection cable. A little bit about the visualization through MaxView. So this is a complete overview of the system itself. And as you can see, we're covering quite big distances. So if we zoom in, we can see individual belts. And again, that's split up then in different zones. And then there's a different type of visualization here. So with MaxView, you can cover all of this. And it gives you a good idea. If an alarm goes, you know exactly where it is, and you can act on that. So what happened? Within a fairly short amount of time, they had a detection of a hot roller. They used the rate of rise alarm for that. So it was not at the 57 to 61 degrees, but it was the rate of rise alarm, which is 5 to 7 degrees increase within a minute. So this isolated the incident to within 30 meters. Is that how we installed the zoning? A maintenance team went then to the particular zone with a thermal camera to inspect that zone, and they found the roller pretty quickly, and it was glowing hot. So instead of a fire, they just replaced the roller and prevented potentially a huge issue there, because if you got coal on fire on a conveyor belt, the fire could have spread over 20 kilometers basically. So the next example we've got is an installation I went through myself in Limerick. It's the Irish cement facility. There is 42 conveyor belts there with 3 kilometers in total in length. We only did a few of the belts there to start off with, and the crew on site, they've installed a few more conveyor belts themselves afterwards, because we gave them some training in how to do that. So this was the frame setup there. So we installed the cable as close as practically possible to the bearings, close to the top roller. So here's where you can see a couple of the pictures of the installation itself. So it was installed in a cabinet, which was IP rated because it was quite a dirty environment. And we hired a local contractor to do some of the fusion splicing. Fusion splicing is needed when you install the unit, but also when you have repairs to the cable. It's basically you splice the cable back together. So it was routed in a redundant loop configuration, as we discussed earlier on. It then went to a splice box, and from the splice box, into the DTS unit itself. And again, different alarm settings here, with a maximum alarm quite low at 40 degrees and a rate of rise alarm at 4 degrees per minute. And lower in the slide here, you can see the zone starts and zone endings for channel 1 and channel 2. And last of all, in Thailand, we did a very big paper factory where alarm settings were used for 60 degrees, pre-alarm at 55. And as you can see, there was quite a few different belts and zones involved there. So we used a 4-channel unit. The unit was installed in the electrical room, and then via network switch, we connected it to a MaxView workstation. And as you can see, this is again a slightly different bearing setup. We also had a rate of rise alarm installed there of 11 degrees per minute. So every situation is different, but the customer was very happy, and they had several sites in Thailand, and 4 subsequent installations were done after the first installation. So benefits of Bandweaver linear heat detection for conveyor protection. First of all, early detection. Smart alarms allow you to detect before the fire occurs. Very accurate detection. You can isolate specific compartments. As we've seen, we can detect within 1 meter. So we can then shut down a belt, for example, and send a maintenance team. It also gives a complete coverage. Cable runs along the length of the asset. We can measure very close to the conveyor belt itself. And it's a very simple installation. Single cable run with no infield power needed. It's only the cable that you need to install, and then from the unit you send a laser light through it. And it's a very reliable system which is not susceptible to corrosion, electromagnetic interference, or radio frequency interference. So a little bit about Bandweaver then. The year of foundation, 2002, so over 20 years, nearly 25. We've so far installed more than 9,000 systems and more than 80,000 kilometers of cable. Not sure how many times you go around the globe with that, but it's a hell of a lot of cable. And the key technology is distributed fiber optic sensing, what we do. So we have a global presence with the main manufacturing site in China, and global sales from our UK office, where we cover everything apart from China itself. These are some of the international customers we've dealt with in the past. I'm not going to name them all because you can see them, but we've dealt with companies from Carlsberg Group to Ferrero Rocher in the food industry to Schneider Electric, Thales, Autostrade in Italy, and Turkish Airlines. The system is also fully approved, particularly for Europe. EN54 is important, which is done by the company VDS. We also have an EX approval for explosion proof when you are in hazardous zones. So the conclusion, conveyor belts, they present a unique fire risk, as we've seen. Fiber optic linear heat detection is robust and reliable, the low cost of ownership. Fiber optic LHD is becoming more and more prevalent in installations because we're spreading the word and people start to know us. And fiber optic LHD provides the most comprehensive coverage, as we've seen with the examples. And Bandweaver has extensive experience in linear heat detection applications, and also a lot of experience now in conveyor belts. So other resources you can visit, please visit bandweaver.com, head to resources or webinars, find the link here below. We also got some videos which you can find at the link below. So thank you very much for attending, and over to the questions next. which hopefully we've received.
Thank you very much, Marinus. That's great. We managed to get a few in all through the email. So apologies for the issue with the chat. As Marinus says, it does show it's a live webinar, and we have indeed got a technical issue with that. So yeah, please do submit at info@bandweaver.com. Yes, we've got a few in. I'll just to give you a breather. I'll take the first few, Marinus, and then we can
Thank you.
divide up after that. So first one, how accurate are fiber optic sensors in differentiating between a genuine fire risk and false alarms due to environmental factors like extreme sunlight or heating systems? And that's an excellent question. The system does detect heat at its core as how it detects. So yes, if something heats to a certain degree, it will register. And so the trick is in the smart alarms of this. So as Marina says, we have all different programmable smart alarms which can be programmed for each specific zone. So you have the maximum temperature where it if it exceeds that, you go off. That's the simplest. You have the rate of rise, where if it raises over a certain period per minute, typically, and normally it's set between sort of 10 degrees C per minute, where it would be over what you would see in a natural environment, but would be what you would see in the event of a fire. So actually, in the Turkish Limak case that Marina's talked about, in that case the alarms were set as low as 7 degrees C per minute, and that was an outdoor conveyor belt. So that's having the sun hit it regularly, heating and cooling. So that they found there when they were setting it up, they were not getting changes according to environmental conditions that were moving it more than 7 degrees C in a minute, but that was enough to detect the heater bearings that came up. So although the general recommendation is 10 degrees C per minute, we can go less than that. And the third smart alarm is deviation, where if you've got something that's moving very slowly in time, you can have an alarm where if one point within the zone goes over the average temperature by a defined amount, then it can alarm as well. So that again would not be detected if the whole area was heated, because the average temperature would rise and you'd only see it for a single point. So with the smart alarms, you can, that's the beauty of them, is that you can configure them to have rapid detection without losing the sensitivity. And our smart alarms have a proprietary algorithm, and I think our next webinar we might go into a bit more detail of that, just to show how accurate it is. But yes, we are able to minimize any alarms due to environmental factors while maintaining sensitivity. Marinus, do you have anything to add to that, or does that sound about right?
I think that's quite an extensive answer.
Yeah. Okay. So a shorter one, I think. In the event of a power failure, does the system automatically restart? Yes. It's designed so that if there is a cut to the power, the system, when the power comes back on, will automatically revert to the last state it was in. So if the system was monitoring, up and running, detecting, it will then go straight back into that. So as soon as you have power coming back in, then you will have that. If it wasn't monitoring, then it will go back to that. But typically I know there's EN standards around what kind of power backup batteries you have, but if the EN systems are not there, it's not got battery backup, we'd always recommend running it off a UPS anyway. So you should always to condition power and prevent the reduce the likelihood significantly of any kind of power failure. That seem okay? Okay, I'll field this one to you, Marinus. Can these systems be installed in existing conveyors, or are they only suited to new installations?
What we've seen so far is that most of the system we install are in existing installations. So people will first install the conveyor belt, and sometimes years after they will decide, okay, we want to install a linear heat detection system. No, normally it's always after an incident has happened and suddenly somebody decides, okay, we need to do something now. So, which is a shame because I think to prevent the fire is always better. So if it can be done at the time when the conveyor belt is built itself, it makes your life a lot easier as well. So you don't have any downtime during the installation. But yeah, in during or after the working of the conveyor doesn't make any difference.
Okay, very good. We did do one on talking about the costs, and someone's come back with a question: how do fiber optic solutions compare in cost with conventional fire and detection systems, both in terms of initial investment and ongoing expenses?
You want me to answer that one as well?
Yeah, unless you want
Okay.
me to. What was the?
Yeah, no. Like the cost of the unit is relatively expensive, while the cost of the cable is relatively cheap. So the more cable you install, the cheaper the whole system becomes per meter. For exact pricing, please contact us, and we'll get you in touch with one of our local distributors.
Yeah, and yeah, I just want to add to that because I've as I said in the intro, I've been in this industry since 1994, so I've seen how much the costs have come down in that. So in 1990s, the only really sort of applications where this equipment was affordable was in road and rail tunnels, and that's where it really became established as a fire detection technology. But over the years, we've seen the benefit of technology developments and wider applications where the user interface has got easier and got better, and the costs have come down, and the user interface has gone up. So we've seen much wider spread applications, and if you're talking, if you're using a system where it's more than a kilometer's worth of cables, if you're using more than sort of 1,000 sensing points, I think, correct me if I'm wrong, Marinus, but I tend to see that we're competitive with any other technologies out there. When you come below that, there's it perhaps is comparable or higher cost when you get down to really small installations. But then even sometimes when the cost is higher, people will choose this for the better location accuracy, the faster detection time, the ability to program with the smart alarms. So the cost of losing your asset is much higher than the initial investment of this, or even just downtime according to that. So we are seeing that, and we are continually pushing the cost down where we'll get it to lower cost even in the smaller installations. Okay. Okay, how resilient is the fiber optic system in the event of a fire, and could it be compromised during an actual fire event?
Did you want to do this one, Richard? This sounds complicated to me.
Yes, yeah. So it's So yeah, there's a there's a sort of short and long answer. So the cable is rated typically in 99% of applications to 85 degrees C. So the cable rating is defined by the components in the cable outside of the fiber optic and the coating on the fiber optic. So typically that's polymers and metal in the armored tube, Kevlar, etc. And the fiber itself typically has an acrylate coating, which is 85 degrees. The fiber optic itself the melting point is 1200 degrees C. So if you want to spend more money, you can improve the temperature rating. So you can go up to 400 degrees C, but we'd only really recommend that if the standard operating temperature is in that, so in furnaces. So what tends to happen in a fire situation, and we've done tests on various cables, is it can survive, up to 3 hours at 750 degrees C. So you can continue to get data, which can be useful in the event, especially if you're connected to other SCADA or building management systems, or something where you're controlling off of that, or you want to know which direction the flames are heading from the how it's going along the trace. So you do have that possibility, but the sort of official recommendation is, if the cable exceeds the temperature rating, which is 85 degrees C, after that event, whatever has been exposed to that temperature rating should be replaced, because you potentially compromise the outer layers of that cable, and those outer layers of those cable provide a valuable function in mechanical protection, either to other layers within the fiber optic cable or to the fiber itself. So yes, if it is exposed to a fire, if it's gone over 85 degrees C, and because you can look back and measure what it was, you should replace that section that has gone over 85. And again, you can look exactly on the trace, see exactly what has been over 85, and you can splice in a replacement length just for that section if needs be. But if we've seen in a number of things, Marina's talked about maintenance systems, these often can detect earlier on, so the fire is suppressed even before flames start, or certainly before the cable's seeing those sorts of levels. So very, very long answer to a simple question. Okay, well let's finish off with one more question, and that's is the laser dangerous? If the cable is cut, could it cause any damage?
No.
Do you want to say that, Marie?
No is the very short answer.
Yeah.
Because the laser is actually a very safe laser. So I wouldn't recommend looking into it. But potentially that wouldn't even cause any damage to your eyes. So the laser is a very safe laser to use.
Absolutely, yeah. It's rated 1M, and it's as safe as DVD player or any other lasers that you see in common practice in consumer products. Yeah. Okay, well, thank you very much, Marinus. I think great job. Good presentation. Again, apologies if you didn't get your question in, but please do send to info@bandweaver.com, and we will get back to you if with any questions that come after the webinar. As we said, you can also download the webinar. The link will be available on our website. I think the email will go out to give that to you later. So thank you very much for your time. Thank you very much, Marinus. I'll let you finish up. Say bye to everyone.
Thank you all for attending. My first full webinar, so it's quite exciting from my side. So thank you all for watching.
All right. Have a great day, everyone. Thank you.